Okay, so for this video here, I'm not going to do a bell work like I usually do, because just to kind of shorten the time of this video. So today we're going to talk about like inverse functions. And inverse functions are functions that are reverse of each other, meaning like they're kind of like switch. But what exactly is switch? Well, it's the x and y's. So when you have a function that are inverses of each other, that means the x and y values are flipped. Which also means like you can say the domain and the range is switched, because we learned in the past that, well, x means domain and y is the range. So one of the things you'll start to get used to is that anytime you see like this f with an exponent of -1, that actually means the inverse of x. So this will take some time to get used to, but just like how now that when you see a dot, you know that is used for a multiplication symbol. Anytime you see like f to the -1 power, it doesn't mean to take it to the -1 power. It just means this is an inverse of the function. It's just used as a notation. So in this example, we'll kind of first try to understand what exactly are inverses. And I'm going to do a very simple example where I just have a set of coordinates. Now we understand that coordinates usually have an x and a y value, right? So if you think back to the definition of what an inverse is when you switch your x and y values. So what I'm going to do is create a inverse relationship of these coordinates, and all I have to do that is switch my x and y values. So this x now gets to be -5, and this y value is a 3 now. And then this one will be a 0, and this one will be a 6, and then this one will be a -7, and that's a +7. So all I did was just switch my x's and y's. So these two sets of coordinates are inverse of each other. So just on a basic level, inverse in mathematics is when x's and y's are switched. So in this slide here, I'm going to show you how you can find an inverse of an actual function or equation. And so in this case, I'm going to break it down into 4 easy steps. So the first step here is for us to understand that typically f of x is not usually written. Like when we first talk about equations, this is not written as f of x. It's usually written as a y, right? So the very first step you're going to do is replace f of x with y. And this is just because it makes it easier to solve. So I'm just going to take this equation, set of f, write a y, and then I'll bring the rest of it down as it was. So everything else still stays the same. Step 2 is to initiate the inverse. And to do that, you have to switch x and y. So basically where x was, I'm going to put where y is. So x gets to be now in the left-hand side and y gets to be on the right-hand side. Everything else still stays the same. So when I do this, notice how y is not by itself before, right? Y now has a 3 attached to it and a 4. So generally, we like y to be by itself. So the next step is to try to get y by itself again. So the third step here is to solve for y, because you want to try to get y by itself so that you can create an equation that represents the inverse. So in this case, I'm going to try to move these numbers off of y. So I have to move over the 4 first. I'm going to subtract 4 to both sides. This cancels. 3y comes down. X minus 4 comes down. Then I have a 3 attached to this y, so I'm going to divide everything by 3. So everything on this side gets divided by 3. Y comes down. There's a 1 technically on this x, right? So I can really write this as 1/3 x. And then I have to divide this 4 by 3, so I can say this is -4/3. And here is my equation. My y is now by itself, so I've basically have done step 3. So once y is by itself, the last step here is to replace y with the inverse notation. In other words, I really should write y as the inverse of the function, so basically f to the negative 1x, and then I'll write the actual equation that I solved down. And so this is the inverse function. The reason why you have to replace y with the inverse is because y in the very beginning is 3x plus 4, so you cannot say that y is this other expression here, or else that wouldn't make sense that y equals two different things. So you have to call it something else. And that's basically it. Those 4 easy steps will help you solve for an inverse function. So what I'm going to do is pause on this journal for a moment, and I'm going to work out and show you how to work out some of the problems on your homework. So if you want to kind of put your journal to the side for a moment, I'm going to turn to page 3 of your packet 9 and work out 2 of the problems. So follow along with me in the next slide here. So this is page 3 of the packet, and I'm doing problem 4 first. So problem 4 is asking you to find the inverse of this function here. So they give you the function, you just have to find the inverse. So we're going to do those 4 easy steps to try to get to the inverse. So the step 1, if you look at your journal, is to find your f of x and switch it, so replace it with a y. So I'm going to grab my function here. Instead of f of x, I'm going to write y equals x cubed plus 3. Step 2 is to switch your x and y. So wherever your x is, make it into a y. Wherever y is, make it into an x. So notice that this got switched. After that, step 3 is to solve for y. So you want to get y by itself. This y is cubed and this y is being added by a 3. So you want to subtract off the 3 first because it's easy to subtract rather than take care of the cube first. So you want to do the easy stuff first. So I'm going to subtract off the 3. So now I just have y to the 3rd power. And then x minus 3 just gets carried down. Now this power here, how to get rid of an exponent is to take a root. So because it's to the 3rd root, I have to take a cube root on both sides. And so that will allow me to cancel out with the 3rd power here. So roots cancel out power. So y drops, and now I just have a cube root of x minus 3. Notice how y here is by itself now. So I'm done solving for y. And then this side here, you do not actually have to take the cube root of x minus 3. You can just leave it as it is. So the final answer for this is, remember, we want to replace y with the inverse function and then rewrite our function that we solved for. So in this case, this is the answer that goes in the blank space. So I'll just rewrite it in the blank space. But this is my final answer. I'll do 5 with you guys as well. So number 5, you have a g, x, 1/3 x minus 5, and you have to find the inverse of g. So it doesn't matter what letters you decide to use. So in this one, they use g, but it wouldn't have mattered if they use k, z, h. You're all going to replace these f of x or g of x with a y. So I'm going to rewrite this equation with y equals 1/3 x minus 5. And then I'm going to go ahead and switch my variables. So I've just switched my x and my y. And now I have to solve for y. So y has 2 things attached to it, but the first thing I need to detach is the 5. So it's much easier to add 5 to both sides first. And then I have 1/3 y on this side, and then I have x plus 5 on this side. So from here, I need to get rid of this 1/3. To get rid of it, I have to there's many ways you can do it. You can try to divide off 1/3 to both sides, or you can do this old trick here. Basically, you take your fraction that's being multiplied and you multiply it by its reciprocal. The reciprocal of 1/3 is 3/1. So I'm going to multiply this side by 3/1. This allows me to cancel out the fractions, bringing down just the y. But here's the thing. You multiply 3/1 on this side, so you have to multiply it on this side. But 3/1 is just 3. So I really just need to multiply by 3 on this side. And so when I multiply by 3, I need to multiply to every single term. So this is 3x plus 15. So 3x plus 15 if I multiply this in. And then from there, I got y by itself, so I just need to replace this with the inverse notation. So this is f negative 1x equals 3x plus 15 as my final answer. And I'll just write my answer in this blank space as well. Oh, actually, I made a little boo-boo. This is not an F. This is a G. My bad. So remember, this is the inverse of G, so I should not be using an F as my letter. Okay, so now that we've kind of got some practice in, I want to show you one more thing that helps connect what we were learning yesterday to what we're learning today. Okay, so sometimes I will ask you to verify if two functions are inverses of each other. So as you can see here in the example, I give you an f function and a g function, and we need to determine if it's inverses. One way you can do this is to verify a functions are inverses is to show these two things. Notice how these are what we learned yesterday. It's the composition functions. So you have to prove that when you plug in g into f, you get x, or you can also prove when you plug in f into g, you get x. But either way, however you calculate the composition function, you have to get x. So oftentimes I just remember this one here because you don't have to do both of them. You could just do one. So I just remember the f g of gx. So what I'm going to do is I'm going to color code this first so I know which one is which. So this one's f, this one's g, and I'm going to use this composition. So I need to start off with the composition, which is f, g, x. And just like what we talked about yesterday, is if you want to solve this problem, you have to start with the inner function. So I'm going to start with g, and I need to figure out what is g, so I can replace the inside here with what g really is. So g is actually negative 1/3 x plus 2. So I'm going to copy and paste that inside. So let me just rewrite this function. So this is f, and I'm going to plug in negative 1/3 x plus 2. And then for the inside here, there's no more g's. Now I just have to deal with this f here. So f is equal to negative 3x plus 6. So I can write this as negative 3x. Now x here is going to be whatever I'm plugging in. And then I have a plus 6 on the outside. So I have to plug in that negative 1/3 x plus 2 in for that x. And then notice how from here I don't have any more f's, I don't have any more g's. So I can just work this out like normal math. I can distribute this negative 3 here. So if I were to distribute this negative 3 to the negative 1/3, that makes a positive number. 3 times 1/3 is actually a 1, right? If you don't believe me, let's work this out. So negative 3 times negative 1/3, I can put this 3 over 1. If I multiply the top across, negative 3 times negative 3 makes a positive 3. 1 times 3 in the bottom gives me a 3. If I divide, that's a 1. So that's a positive 1, but there is an x here, so I need to bring down an x. Then negative 3 times 2 gives me a negative 6, and then I have to bring down this positive 6, so that's a positive 6 down. Notice how these two terms cancel, because that's a negative 6, that's a positive 6. So all I'm left with is 1x, or in other words, I'm just left with x. So I just proved that when I plug in g into f, I just got x, which means, based off the definition here, that f and g are inverses. So if you get the output to be x, you can say, yes, they are inverses. And you're done. So basically, if it doesn't equal x, you have to say no, they are not inverses. So let's try out some of the homework problems together so that way you guys get more of a feel. All right, so here number 7 and number 8 here, I have to determine if they are inverses of each other. So I'm given two sets of equations. So I'm going to start with this one here. I need to prove that these two are inverses of each other. And to do that, I have to start with my composition function. So I'm going to use the one that I like, and it's just plugging g into f. And so when I do this, I need to replace my g, the inner, with what it actually is. So I'm going to color code here. So g is going to be pink. And so g on the inside gets replaced with what it actually is, which is 2x minus 3. So I'll write here 2x minus 3. And now I want to get rid of f. So f's function is 2x plus 3. So I'm going to outline that here in the bottom. So I'm going to write the 2 down. Instead of the x, I'm going to put an open parentheses and then the plus 3 on the end. Now, in the open parentheses, I am going to plug in what I'm supposed to, which is the 2x minus 3. So I'm going to plug in 2x minus 3, and then I'm going to go ahead and distribute the 2 in to try to simplify this. So I get 4x minus 6, and then I have a plus 3 outside, so I'm just going to carry that down. And if I simplify, this is really just 4x minus 3, but looking at it, that's all I can do. And this is my final answer. So my final output. And this is not f of x. This is not f of g where it equals x, right? So this does not equal x. So I have to say this is not an inverse because it does not equal x. This one, let's try if this one's an inverse or not. So again, you're going to do the same type of setup. I'm going to use the f plug in g. So I'm going to start by replacing g with what it actually is here, which is the 1/6x. So if I were to do that, this is f. Oops, let me grab, not my highlighter, my pen here. So g is 1/6x that I replace. This is saying that I'm going into, I'm going to be plugging this into f. So here's f. It's negative 6x. So I'm going to bring that down as negative 6. And then I'm going to put parentheses where the x would be and plug in what I need to plug in, which is the 1/6x. So if I plug that in, 1/6x, I need to work this out. So when you multiply a negative 6 with 1/6, the 6 will cancel, bringing down just the negative 1. So you have really a negative 1x, but a negative 1x is just negative x, right? And here's the thing, I can't really reduce this anymore. Like, this is really all I can do. And looking at it, that's actually not the x that I want, right? This is a negative x. So this is not an inverse because there's a negative in front. So I have to say this is not an inverse as well. So it has to be just a 1x in order to be an inverse when you use the composition functions to test it out. All right, that's it for this journal. I hope that helps you with your homework. Until next time.